Hello, my name is Werner Scholz. I'm CTO and Head of R&D at Xenon Systems, and I welcome you to our presentation on transforming HPC clusters with modern architecture and configuration management. Xenon Systems has been involved in the delivery of high-performance computing solutions for more than 20 years. We've delivered render farms to movie studios, we've delivered HPC clusters to customers like VPAC and CSIRO. We've been involved in the deployment of some of the largest HPC systems in the country. We've also delivered HPC solutions to AI startups, to biotech companies, and commercial customers, and we've been supporting them throughout the lifetime of the systems and even managing them on a daily basis for our customers. So what are some of the challenges we've come across when managing these systems? The software stacks that are available today are often based on outdated monolithic architectures and old-style configuration management. Maintaining security of the systems, including system network and access protection, can be a challenge. Software updates, including OS and patch management, are challenging in HPC cluster environments, and the whole setup from the initial installation, configuration, the testing and acceptance can take quite a long time. Also, the integration with existing infrastructure in the customer environments and integration with access management systems can pose significant challenges. In addition, HPC clusters nowadays are often heterogeneous systems with different CPU architectures, different accelerators, and of course also hybrid cloud solutions. In addition, the HPC cluster should be scalable. It should be easy to add compute, storage, and network components, but then all these new and different infrastructure classes need to be integrated and managed appropriately. Data management is a whole topic in itself, including the performance tiering, protection, backup, and archiving. The systems need to be monitored continuously to ensure performance and availability of the system. And of course, the workflows need to be developed, integrated, regularly changed and updated to fulfill the customer and user requirements. And there are also new trends with different applications and libraries, different dependencies, containers, changing workflows, and changing tools. With that, I'll hand over to Xenon Senior Solutions Architect Jakub Salad, who will take you some of the details and then some of the solutions we found in this space.
Thanks, Werner, and hi, everybody. I'm sure everyone's had the likes of Amazon, Microsoft, and Google come telling us how we should just pick up your HPC cluster and run them fully in the cloud. That's all very well until your credit card maxes out after about a week of workloads which have been running consistently for 24/7. In the end, there are some workloads that lend themselves perfectly to the cloud and some that don't. This is where hybrid clouds come into play. Handling the compute part is relatively easy, with virtual instance capable of auto-scaling, being able to be integrated into an on-premise HPC scheduler. This allows for growing out public cloud nodes as deemed required, and serviced by a dedicated queue on the scheduler. The use of dedicated queues is best to make sure users understand there is a difference in the way a job runs. Sometimes magic simplification of HPC world only brings pain to both the admins and the users when things don't exactly work where we were expected and everyone is upset, causing the workload is not where it should be. In reality, the true challenge is data. Workloads with small data sets or public streaming sources work best as cloud workflows. It's always important to consider latency of direct access or time to stage data in and out when considering workloads that would run in the cloud. There are some of the challenges that many storage vendors are working on solutions to assist with. Some are doing better than others. Some approaches to the challenge include storing data in S3 buckets and providing fast caches to compute cloud nodes, either with or without a parallel file system made available. It's also important to remember to consider the entire data lifecycle, including backup, where and when required, security, and cost. One of the big gotchas is that large costs associated with bringing data back to on-premise, if that is required, part of a workflow. Some other solutions run full parallel file system on cloud instances, but this can cost an arm and a leg, as it has to keep on running in most cases 24/7. Thus, a blanket approach to workflows in public cloud does not really exist. The point we're trying to make is that workflows need to be carefully considered in relation to being used in the cloud. In the end, public clouds are very easy to consume, and thus have lots of money to burn. Hybrid clouds hold the future, whereby some carefully considered workloads are burst into the cloud when resources are required beyond what is available on premise. In some part, many clusters are already deployed with some automation tools. Many rely on commercial inflexible cluster management tools, which are restricted to what they can do, and are not scalable to hybrid cloud, which we talked about. So why not bring cloud automation to the on-premise clusters? Or, as one of our customers calls it, off-cloud. Be it bare metal or private or public cloud VM instances, current open source automation tools can be used to help configure and scale clusters to utilize what would otherwise be wasted resources. There are many tools out there, so why not use something like Ansible to automate cluster maintenance, including compute node, admin containers, and even network infrastructure. Many vendors are moving to and providing Ansible roles and playbooks to make everyone's life easier. These Ansible playbooks are able to be easily shared, modified, and extended. Integrating cloud-based capabilities with that of traditional clusters becomes simple with this approach. Some other benefits include being able to bootstrap deployments, even off a laptop, due to a low infrastructure requirement to run Ansible. Now, the same code that is used with the public clouds to automate their cluster deployment can be ported into the hybrid cloud with a head node residing on-premise and nodes being both on-prem and in the cloud. On-prem can then consist of both traditional bare metal instances, where true performance is required, and that of nodes deployed in private clouds by VMware or OpenStack, for example, where codes can be trailed or sometimes they can even be sufficient for many of the workloads. These automation tools can keep systems updated while remaining truly flexible, which some of the current commercial HPC cluster management platforms lack. Remaining agile as circumstances change in the fast-paced IT environment. Modern can be defined as flexible, agile, whilst being modular. So to be modern, you must have modular components that are flexible, with alternate replacement, and agile, no or little impact and change. And this is why many vendors from storage to networking are utilizing containers in their solutions. HPC cluster software stacks should be no different. Having containers providing head node services and different containers providing web GUI for end users, such architecture just brings to it. Removal of dependency mess, which makes updates and patching of one component so challenging. Ability to shift components to alternate systems or even to cloud. Swap in and out components easily to suit the overall environment, for instance, authentication integration with central IT. Allowed to leverage best-of-breed components that can be replaced as the trends alter. Deploy components to bootstrap clusters on laptops for fast system stand-up or utilize cloud for fully cloud-based workloads. We at Xenon Systems have combined the most useful and stable open source set of tools in Docker containers to provide our clients just that. We call it Xenon Cluster Stack, which is just a combination of Docker-based containers comprising of components such as Open On Demand for end users interfaces and Ansible for cluster admins, just to name a few. Furthermore, we encourage the use of containers via Singularity to further remove a dependence on the OS flavor being used to power the cluster, and being able to leverage NVIDIA GPU Cloud (NGC) to provide different versions of software such as TensorFlow, PyTorch, and many other tools available there. This lowers the requirements for HPC admins having to compile and maintain large software repositories, which everyone has currently. The slide depicts also an implementation of a Xenon cluster stack at one of our clients for a self-contained, simple-to-manage Slurm cluster. This approach addresses many of the pain points Werner had outlined in the start of the presentation and provides an easy path to adopt and deploy as the HPC world alters and changes around us. We would like to thank you for your time and we hope you enjoyed the short talk. We'll be happy to answer any questions now, or feel free to contact any of us or any other Xenon team member.